In an attempt to level gender inequalities, a survey of the toilet facilities provided by universities across Kenya found there was a striking difference between the number of toilets available to girl students when compared with those for the boys. Accordingly, individual universities were asked to report how many male toilets and how many female toilets there were per student. At one, it was found that there was an average of just one toilet for every 38 girls, while the overall average of toilets for all students, male and female, was 26. How unfair is that? This is an interesting problem, and it's a little tricky, but the maths is quite simple when you break it down. There are only a few elements here. First, to calculate how many boys there were per male toilet, the administrative officer took the total number of students, which he called P. Then, as the students are divided equally between boys and girls, he established the number of boys to be P over 2. And the number of girls is also P over 2. As he knew there was 26 toilets per student, he was able to establish there was P over 26 toilets in total. Finally, as he knew there was only one toilet for every 38 girls, and had established there were P over 2 girls, then it follows that the girls have only P over 2 divided by 38 toilets. To express this as a fraction, he wrote it as P over 38 times 2, which is the same as saying P over 76. So now the administrator has expressed mathematically both the total number of toilets and the number of female toilets. So he can easily get the number of male toilets simply by deducting one from the other, namely P over 26 minus P over 76. This takes us into the realm of fractional arithmetic, which you will easily remember from primary school. Just in case you've become a little hazy about how it works, let's do a quick recap here. But fractional arithmetic is also very easy. To add a half, namely 1 over 2, to 3/4, 3 over 4, you create a common denominator. That's a number which is divisible by all the bottom numbers. A good way of finding that is to simply multiply the bottom numbers together, which gives us a common denominator of 8. To add the two fractions together, you simply divide the common denominator by the bottom number of each fraction, then multiply the result by the top number. So 2 into 8 goes 4 times, and when you multiply 4 by 1 you get 4. In the next fraction 4 goes into 8 twice. When 2 is multiplied by 3 it gives 6. This, then, is 4 plus 6, which is 10 over 8, or 10/8, and that's the answer. But that's not how we normally write it, so divide the bottom into the top and 8 goes into 10 once with 2 over. And 2 over 8 is the same thing as 1 over 4. Fractional multiplication and division is similarly easy. Consider a half times a quarter. Well, we know that's going to be an eighth, and so it is. Simply multiply it across. 1 times 1 is 1, and 2 times 4 is 8. Fractional division is much the same. Consider a half divided by a quarter, 1 over 2 divided by 1 over 4. To resolve it we turn the divide part over then multiply. We know a half divided by a quarter is 2. 1 over 2 times 4 over 1 is 4 over 2, which is, of course, 2. Well, that's enough about fractional arithmetic. So let's get back to the toilet survey. We were looking at how the university administrator calculated the number of boys' toilets by deducting the girls' toilets from the total. To resolve this sum we need a common denominator, a number which all the bottom numbers will divide into, and a quick way to get this is to multiply them together. 26 times 76 comes to 1976. Now to resolve the fractional subtraction, we simply divide the bottom part of each fraction into the common denominator, and multiply the result by the top part. 26 goes into 1976 76 times, and 76 multiplied by p is 76p. In the same way the other fraction reduced to 26p. So in the end we come down to a straightforward subtraction, 76p less 26p is 50p. And 50p over 1976 is the number of male toilets in the university. Fantastic, fantastic. But not very useful, and furthermore, it's not the answer. The university administrator was asked for the ratio of boys to male toilets, not the number. He knows how many boys there are, and he knows how many male toilets there are, so to get the ratio it's simply a matter of dividing one by the other. This is what the sum will look like. The number of boys is p over 2, and he's just calculated the number of male toilets to be 50p over 1976. To divide a fraction by another, we simply turn the division part upside down, and multiply. When multiplying, if you get the same number on the top and the bottom of the fraction, you can simply cross them out. So there goes p, and what we have left is 1976 over 2 times 50, or 1976 over 100, which is a simple division and works out to 19.76. Therefore, the survey exposed that male students have access to twice as many toilets as female students. A depressingly discriminatory statistic, no doubt helped by the fact that urinals count as male toilets whereas all female toilets are in cubicles. It's an interesting riddle though, and one typical of those the great universities like to ask candidates for their master's programs. To resolve it, however, requires a minimal amount of mathematical knowledge, in fact little more than that which is taught in primary school. But to apply this in real-life situations requires the sort of lateral reasoning needed by talented software developers and data analysts. The following questions will test your understanding of the topic. If you found it interesting and informative, click the Yes button to continue the questions, or you can click No to skip the questions and move on to the next topic.